breast cancer and early detection of breast cancer is considered the best way to reduce mortality. Mammography is widely used to detect cancer. This article discusses the basic work we have undertaken to implement a mammography data warehouse to encourage medical and investigative activity. I pass. 2,600 new instances of breast cancers. It's a big number. The big number is growth are enlisted each year in Tunisia, which called arrive at 3,800 cases by 2024, and indicated by the leader of the Tunisian Association for Breast Cancer decision. Most information about malignant breast growth can be dispersed from various sources, making it difficult to obtain clinical data systems such as hospital information system, radiological information system, and image archiving and communication system. PACS generally have prerequisites for carrying out activity and are highly reliable. Many problem in Tunisia in health system. For example, Tunisian general health system, like that of several different countries, has real problem in the commission data, and considering that within a limited time frame, it is not ready to manage its requests and control its assets. In Tunisia, the first step was taken to solve this problem. The Tunisian government Ministry of Health is concerned about the public circulation of social insurance assets and have enacted laws and procedures on public system medical service arrangement and joint. One of these processes is the star model, the star diagram. We will see the diagram after. The content provided for the medical data warehouse describes in detail the resource, facility, and activity related to the public healthcare system. Many problem, for example, in health system, hospital system, and the health in Tunisia. For example, looking for the right people with the right data becomes a fastidious and manual task. Update data with Excel by a single person, problem for information transfer between hospitals, surgeries, clinical, problem to information access, problem to knowledge extraction concerning a patient, a diagnostic treatment, problem of time consuming in the configuration, the admission, and the compilation of data to get dashboard up to date. To eliminate this problem, to reduce the problem, we propose a data warehouse, a mammography data warehouse. It have emerged for two reasons. First, the need to provide a single, perfect, and consistent source of data for decision support. Second, the need to do it as such without affecting operational systems. To make decision, our work proposes a data warehouse analysis framework for analyzing data related to breast cancer in Tunisia. Many medical frameworks in image. In medical image, neuroimage, breast cancer, tumor, and all. For example, XNAT, IDASH, CAT-REAP. We checked on biomedical writing for translational platforms permitting the administration and investigation of medical data, and identified a few openly accessible platforms, for example, XNAT, Extensible Neuroimaging Archive, Toolkit, iDash, Transmart, Catrip, many platform. For example, XNAT was conceived to capture data from multiple sources to keep the data in secure medical repository and diffuse the data to permit user. The benefits of XNAT is add common productivity and manage tasks of neuroimaging and related data, secure access to user interface and data archive. The limit, it's important to note that the archive is actively managed by domain knowledge staff. Per expert staff is difficult to manage XNAT and the data stored in XNAT. Data warehouse, the classical data warehouse design contain multiple components which make it a rich environment of information storage, especially operation source system, transition zone, visualization zone, data access tool. First, the primary component of the data warehouse is the operational source system, which incorporate different heterogeneous information source with various structure and arrangement. For example, relational database, level document, spreadsheet, and other. Um, uh, we uh, we used in this paper two type of data: textual data source, for example, patient demographics from Salah Azai's hospital information system in Tunisia, symptomatic mammogram imaging report for the Salah Azai's RIS system, which will be a significant resource of radiological discovery, related patient history information gathered from paper-based clinical record at the breast imaging section of the hospital. The other type is imaging information, selected mammogram films chronically in the breast imaging section will be filtered using Lumis's laser scanner and put away into the proposed data warehouse mammography data warehouse data warehouse. Mammogram imaging are a critical data source for medical decision. As of now, accessible data recovery and decision support system depend fundamentally on the extracted content. We will probably discover promising methodology for giving clinical proof at the purpose of service using data contained in the medical text and mammogram imaging. We examined two ways to deal with finding illustrative proof: a supervised machine learning approach in which mammogram imaging are delegated being applicable to a data need or not, and a pipeline data recovery approach in which pictures were recovered using related text and afterward ranked using continent-based image retrieval (CBIR) methods. In this work, we present and incorporate order and retrieval-based diagnostic guide for tumor cancer recognition by removing and consolidating a few profound highlight by using move learning and multi-reaction straight relapse MLR based meta learning approach. The second element component is the data staging zone, which include a few information pre-processing assignment, for example, management of cleaning, joining and normalizing data, storing and arrangement, and consecutive preparing. The third component is the introduction zone, where the information are organized in data marts in view of unique business process. In addition, the data mart are adjusted in a normalized manner to be additionally incorporated. The last components introduced the data access tool, which incorporate ad hoc query, outfit, textual report, analytical application, data mining, and other. A data warehouse is implemented for purpose of analysis and to assist in the company's strategic decision. We propose a medical analytical framework. The framework comprises components that flexibly the necessary function to get ready and integrate data into a data warehouse store. Besides, it gives to get to instrument to create complex analysis of this data. The image medical analytic framework environment illustrate the medical analysis framework wherein we can perceive how the components are composed, how data are moved from data source to the data warehouse system, and how doctors can get to data. The primary component is our framework speaks to the general medical system data source. For example, the source of breast imaging and textual reporting. The second component is the medical operational data store. MODs, where the information is integrated through a typical and structured format. The third component is the mammography data warehouse, which was structured using the dimensional displaying technique. In this manner, star diagrams were executed through the meaning of dimension and fact tables. The last component is the OLAP service which permit doctor to get to the dimensional data put away in the medical data warehouse. The medical data warehouse, the star diagram. The augmented star diagram, these star diagram are appeared in this figure. Showed the data layer design of medical data warehouse. The design medical data warehouse uses a denormalized diagram or as a pair in the star diagram. The dimensional tables such as dim patient, dim date, dim hospital, dim image detail, dim image contain denormalized or repetitive data such may expedite data mining and business intelligence procedure. The fact tables have the same dimension but a different level of granularity. Each fact table gets it one measure group. Fact tables below demonstrated the fact and dimension table of the medical data warehouse in detail. Two fact tables, the fact table that describe the subject matter are named fact diagnostic and fact forecast. The table consists of the case ID patient, ID hospital, ID date, ID image. The fact diagnostics consists of two measurements, the diagnostic statue and the treatment results. The fact forecast table consists of the measurement risk factors. Dimension tables, we have 5 dimension tables that detail every element in the fact tables. Before diagnosing breast cancer code, we use the HEL tools. We might change to enhance all the undertakings of information readiness and loading from modes to medical data warehouse database. OLAP server. OLAP server, a the cube is developed dependent on dimension of a medical data warehouse so as to perform OLAP activity. It's structured and actualized by using SQL Server analytical service, the dimension and the picking order are actualized to permit applying all up activity, size, dice, drill through, the drill up and drill down to powerful hierarchy and actualized, which are the date and address hierarchy. All dimensions are picked to construct the cube. This figure show the analysis in the implementation of actualizing the SAS package. The following stage is to see the cab using SMSS permit the expert to see the subsequent cube by dropping each dimension part without any problem. In additionally, give filtering condition to pair a few value or add more value to get accurate outcomes. These figures show the number of explicit disease breast cancer tumors characterized by a fourth of the year for a particular gender female. The analysis can likewise gathering numerous diseases for some area and sex. These figure show the analysis result of filters applied on bracelet cap. The output file additionally developed with a entrance database that held more than a high number of clinical records. A significant number of determining attributes are included based on the first property, for example, age, class from age, day, month, year, quarter, and session from date of finding. Some change from are applied for example, evacuating space inside the tray, quality, and changing of a sexual gender into a unit character, male into M, female into F, and other into U. These figures show the breast tumor disease characterized by gender and age class. Each shading speaks to the age class and show the exact number of contamination. Clearly, age class 5, 40, and 65 years are tainted with high rate number among the other age class. The validation of the medical framework for validation, we use this survey adjusted from the computer system usability questionnaire CSUQ is made out of 10 questions. To conclusion, in this paper, we proposed the execution of a medical analytical data warehousing framework to helping public healthcare system to giving information and a tool set to performing complex analysis. As future work, this framework requests enhancement with respect to information insert and update in mods. The flexibility of information by the cities is fundamental for the data maintenance of medical framework. Analysis of framework, I use this reference for my presentation. Thank you very much. This presentation is for the International Conference of America. Thank you very much.